Welcome to the Safety Benefit Cost Analysis video for the Missouri Department of Transportation. This video corresponds with the MoDOT Engineering Policy Guide, EPG 905.3.6.3.1. Key takeaways from this module include an overview of a benefit cost analysis, how to estimate the monetized value of safety project benefits, the typical approach to estimate safety project costs, and how to determine the anticipated service life of a safety project countermeasure. Let's begin with an introduction of this video. A benefit cost analysis, BCA, is used to determine if safety improvements are economically feasible or if the potential benefits are greater than the anticipated costs. Which traffic safety countermeasures would provide the greatest benefit? This factors in cost of the countermeasures. Comparisons can be made to determine if an improvement at one location would be more beneficial than the same or another improvement at another location. This module provides an overview of the following: benefits, costs, service life, BCA calculation, and documentation. Now that we've introduced the safety BCA, let's discuss the benefits of a safety project. The benefits of a traffic safety project are determined by calculating the total reduction in crashes and should be represented by HSM expected values when possible. This value can be calculated by using one of the various tools, HSM spreadsheets, ISAT-E, IHSDM, mentioned in MoDOT EPG 905.3.6.2. MoDOT typically calculates safety benefits based on a reduction of crashes. These crashes are multiplied by a dollars per crash value based on periodic FHWA determined values and adopted to Missouri's Consumer Price Index. Contact the MoDOT Project Core team for the appropriate values to use for this study. The resulting benefit is in dollars saved due to crashes reduced. It should be noted that a negative number is possible and represents an expected increase in crashes. Crashes reduced due to proposed safety improvements should be calculated for the service life of the improvement. Modeling tools such as HSM spreadsheets, ISAT-E, and IHSDM can be used. In particular, ISAT-E and IHSDM can be used to estimate future crash performance with and without the potential countermeasures. However, they should be calculated for the present year of their countermeasures' service life to be accurately compared with the typical cost analysis method. MoDOT has also developed some estimator tools for systematic treatments like median cable barrier. Reach out to the MoDOT Central Office Highway Safety and Traffic when valuing systematic treatments. MoDOT typically calculates the total benefits of all crashes reduced, in addition to considering the total benefits of only the fatal and serious injury crashes reduced. Reducing fatalities and serious injuries on Missouri roadways is a primary goal for MoDOT. FHWA's Crash Costs for Highway Safety Analysis states that a crash results in tangible and intangible consequences. The tangible consequences, or economic costs, can be directly measured in monetary terms, for example, medical bills or lost wages. The intangible consequences, such as the physical pain and emotional suffering of people injured in crashes and their families, comprise the other impacts of crashes. Therefore, the value of reducing a fatality is significantly more than a property damage-only crash. The total benefits are calculated as follows. The sum of all countermeasure crashes reduced multiplied by the associated crash costs. In the formula displayed, CCR is short for Countermeasure Crashes Reduced, and ACC is short for Associated Crash Costs. Note that all project benefits should be calculated in present year dollars, which will require adjustment factors to refine future year benefit values to present day. The following cost sections will further explain how to estimate monetized values in present year dollars. Now that we've looked at safety benefits, let's discuss safety costs. Every traffic safety project has a variety of associated costs. MoDOT typically assumes that safety costs represent the Highway Safety Improvement Program, HSIP, programmed amount for safety improvement construction. General guidelines for costs include: right-of-way costs are only included if the purchase of right-of-way is necessary to install a safety treatment. An example would be adding shoulders, which would change the ditch line and require additional right-of-way. Typically, engineering, design, construction inspection, and other incidental costs are not included, even for projects that are entirely safety improvements. Only construction costs associated with the safety improvement should be included in the cost analysis. If shoulders and rumble strips are being added during a resurfacing job, costs associated with the resurfacing should not be counted. Routine maintenance costs is typically not included in the project costs if the cost is minor, such as the installation of warning signs. However, if significant maintenance is required on an annual basis, such as for median cable barrier, then it should be included in the project costs. Now that we've discussed safety costs, let's look at the service life of a safety project. The service life of a proposed improvement refers to its anticipated useful life. For example, a bridge would be expected to have a much longer service life than a warning sign. Service life information is used in the benefit cost analysis to factor the expected useful life of the proposed countermeasure and should be collected on all items associated with the construction of the safety improvement. The CMF Clearinghouse, as well as MoDOT's pre-approved list of CMFs, provides a comprehensive listing of available service life information for commonly used traffic safety countermeasures. The information is provided by several states and organized consistently with the 15 countermeasure categories currently listed in the Clearinghouse. 3 additional categories of resurfacing, structures, and other are also provided. Links to tables for each category are shown, and each state's service life information is listed if it is available. The table on this slide displays an example of the service life displayed in years for a sampling of a few different countermeasures. The service life values are based on the Missouri HAL manual and the CMF Clearinghouse. For this example, installing a traffic sign would have a likely service life of 6 to 8 years, and widening or improving a shoulder would have a typical service life of about 10 years. Both example values stated are per the Missouri HAL manual. Ultimately, the project team should decide what an appropriate service life is for an improvement because some sources may have a range of values. A valuable resource to refer to is FHWA's Countermeasure Service Life Guide. Now that we've looked over project service life, let's discuss the BCA calculation methodology. After quantifying the total benefits and costs for the project, the benefit-cost ratio can then be calculated as follows. BCA is equal to the total benefits divided by the total costs. If the BCA has a value of greater than 1, then the anticipated benefits of the project outweigh the costs. The BCA ratio can be used as a comparison tool for countermeasure selection. However, it is ultimately up to professional judgment and MoDOT coordination to determine the best possible countermeasure for the project rather than selecting the option that results in the highest value. MoDOT typically calculates two BC ratios. One BC ratio incorporates the total safety benefits using all crashes. The other BC ratio is referred to as a priority BC that only focuses on fatal and serious injury crashes. The use of the priority BC analysis allows the department to focus and prioritize safety projects that will maximize lives saved over a project that reduces property damage only type crashes. Other factors, such as the required time to implement and total costs, should also be factored into the decision. While the BC must equal at least 1 in order to be eligible for safety funds, the intent of safety projects is to save the most lives and reduce the most serious injuries. Now that we've reviewed the BCA calculation methodology, let's discuss the general documentation approach for MoDOT safety projects with the BCA. The calculation of benefit-cost ratio should be well documented and cataloged for future reference. The number of anticipated lives saved and serious injuries reduced should also be documented. This will be helpful not only for projecting costs and benefit of future projects, but also for evaluating benefit-cost analysis of past projects. Suggested items to document include study location, date, and proposed countermeasures, as well as information used in the benefit-cost analysis, such as project costs, service life, CMFs used, and corresponding reference numbers, if applicable, crash costs and crashes reduced. It is also important to include the required information for HSIP reporting, such as categories, AADT, and speed. It is also recommended to document any special circumstances that may have had significant impacts to either costs or benefits. For example, a special circumstance that may be worth noting and would have an impact on benefits are locations that deploy an interim countermeasure. Significant impacts to cost should also be accounted for, as these are typically calculated on a location-specific basis. Now, let's discuss key takeaways and additional resources. The revisited key takeaways from this module include an overview of a benefit-cost analysis, how to estimate the monetized value of safety project benefits, the typical approach to estimate safety project costs, and how to determine the anticipated service life of a safety project countermeasure. In addition to MoDOT EPGs, more information can be found in the MoDOT Safety Handbook for Locals, SHAL, the FHWA CMF Clearinghouse, various FHWA reports and manuals, and U.S. DOT BCA guidance for discretionary grant programs. Time to see what you know. Question 1. MoDOT typically calculates the total benefits of what? Is it A, all crashes reduced only, B, fatal and serious injury crashes only, C, property damage crashes only, or D, all crashes reduced and fatal and serious injury crashes reduced? The correct answer is D, all crashes reduced and fatal and serious injury crashes reduced. Question 2. True or false? A BCA can be used to inform decision makers of the economic feasibility of a safety project or which countermeasures may provide the most benefit. The correct answer is true. Question 4. Which statement is incorrect? A. Service life is the anticipated useful life of the proposed improvement. B. The anticipated service life of a sign replacement is longer than that of a bridge replacement. C. The CMF Clearinghouse provides available service life information for common countermeasures. Or D. The service life is used in a BCA to factor expected useful life of a countermeasure. The correct answer is B. The statement should have stated, the anticipated service life of a sign replacement is shorter than that of a bridge replacement. Question 5. If the BCA ratio is greater than 1, then A. Anticipated benefits outweigh the costs. B. Anticipated costs outweigh the benefits. C. There has been an error made in the calculations. Or D. Present year dollar values will be larger than future year dollar values. The correct answer is A. If the BCA ratio is greater than 1, then anticipated benefits outweigh the costs. Thank you for participating in the TIA Guidance Safety Benefit Cost Analysis module. MoDOT encourages you to view the other TIA Guidance Learning modules. If you have any questions, please reach out to MoDOT Central Office, Highway Safety and Traffic.